Hello, here we start the last section of the differentiation chapter, which involves rates of change leading into solving differential equations. Basically, this is not really complicated. You just need to differentiate and rearrange. And you know how to differentiate, you should be able to rearrange. It's just figuring out what moving pieces we need to put into place. I'm going to go through a few examples first, and we're going to take it from there. Here they tell me that the area of a circle is given by the formula pi r squared, but they tell me that the rate of change of the radius relative to time that's what dr over dt means. Dr over dt is the rate of change. So we have a circle where the radius changes over time. It's getting bigger, it's getting smaller, I don't know. So dr over dt, the rate of change of the radius relative to time, is 5. So they want me to find the rate of change of the area relative to time over time when the radius is 3. So what's happening there? When the radius is 3, at what rate is the area changing over time? Now, if you think about it, you want to find dA over dt. That's what you want to find. Well, that's going to be equal to, I know dr over dt, okay. I'm going to multiply this by something in order to get that. The dt is already there. The dr needs to disappear. So I'm going to multiply by something over dr because then the drs will cancel out. What do I need here? I need dA, isn't it? So I need to find the derivative of the area relative to the radius. So I need to find from here dA over dr is actually 2 pi r. So dA over dt, which is what they're asking me to find, is dr over dt, which is 5, times dA over dr, which I've calculated, is 2 pi r. So dA over dt is 10 pi r. When the radius is 3, it'll be 30 pi. And that is the most straightforward example the book I can show you on how to use rates of change to solve these kind of equations. Let's look at another one, a bit more complicated perhaps. Moving on to example number 2, this one is a bit trickier. So they tell me that the volume of a sphere is given by the formula 2/3 of pi r cubed, that we should all remember. The surface area, the total surface area of the sphere is given by 3 pi r squared. And they tell me that the rate of change of the volume over time is 6, dv over dt. They want me to find the s over dt. Now, the way I would tackle this question, we know we're going to have to do some manipulating, we're going to have to do some differentiating. So I'm going to differentiate first and see what moving pieces I can use and take it from there. So first of all, I can find dv over dr, which is going to be 2 pi r squared. I can find ds over dr, which is 6 pi. I know dv over dt is 6. I want to find ds over dt. So with those three moving pieces, I need to find ds over dt. So I'm going to do the same thing I did before. ds over dt is going to be equal to something times something. Well, I've got ds over dr. So that's fine because the ds is going to be, but I need to get rid of the dr. How am I going to get rid of the dr? I'm going to have to multiply it by something that has got dr at the top, which from here, there, and there, well, it's not going to be that because I've already used it here. It's not that because it doesn't have a dr, and here, dr is not in the numerator, but I can invert it. So I can do dr over dv which would be the inverse of that. But now I've got ds over dv, so I need to get rid of that dv. So I will multiply by dv over dt, which is there. dv over dt. It's a bit like in chemistry if you've done conversion factors, isn't it? Because dr and dr cancel out, dv and dv cancel out, and I've got ds over dt, which is what I'm looking for. So ds over dt is going to be ds over dr 6 pi times dr over dv, which is the inverse of that, so 1 over 2 pi r squared times dv over dt, which they told me was 6 pi 36 divided by 2 is 18 over r squared, and there you go. That's the answer. So you just figure out what your moving pieces are, and then you can invert them, multiply them together, arrange them in the order that you see fit to get you to the answer that you need. Hopefully that's clear enough.